Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You have homework about sound waves, paper 1 for core and extended candidates. Question number 1, we have an astronaut and this astronaut is using a hammer to mend a satellite in space, and we have astronaut 2 nearby. There is no air in space, which is vacuum, no particles, compared with the sound heard if they were working on Earth. What does astronaut 2 can hear? As you know that sound waves are mechanical waves. What do you mean by mechanical waves? Mechanical waves, they require a medium to travel through it. So sound waves, they are mechanical waves. They cannot travel through vacuum or space. So in this case, no sound in space, no sound at all. So astronaut 2 will not hear any sound if you compare this if they were working on Earth. Can you please write in the comments what are mechanical waves? If you know other examples for mechanical waves, write in the comments. Okay, question number 2, we have here which row gives you the nature of sound waves and the name of the effect causes an echo. An echo, it means repetition of sound due to reflection. Repetition of sound due to reflection, so you have to exclude refraction and refraction. You have to exclude also that sound waves are transverse. No, they are longitudinal waves. So sound waves, they are longitudinal. Particles vibrate. If you have here the direction of wave travel, how the particles vibrate. If you have sound in air, for example, they vibrate to the right and to the left along the direction of wave travel. And echo, again, it means repetition of sound due to reflection. So this is the answer of question 2. Okay, question 3, you have here a diagram representing waves of four different sources of sound. Why it's important to know information about sound source? Because here frequency of sound depends on the source. Frequency depends on the source. So if you have different sources, it means you have different frequencies. Which sound here has the highest frequency? I told you in the classwork that you can count waves because frequency means number of complete oscillations, vibrations, waves produced per second, and it's measured in hertz. But you can just check the wavelength. So you have wave equation. If you have constant speed, it means the greater frequency means shorter wavelength. They are inversely proportional if you have a constant speed. And by the way, speed also depends on the medium. Speed depends on the medium, okay? So now if you compare all the diagrams you have, you will check the shortest wavelength is here. The shortest wavelength is here. This wavelength. Here we have wavelength is longer. Here we have wavelength is longer. Okay, so the shortest wavelength is D. when frequency is high. So shorter wavelength means higher frequency. Is it clear? Question 4 here we have a pulse of sound is produced at the bottom of a boat, and you have here the sound reaches the boat again after 1.3 seconds. So the time taken here for the sound to be reflected back, it took 1.2 seconds. Using this information to calculate the speed of sound in water. You know that you can apply equation speed of sound in water is equal to twice using echo. Okay, using echo, you have here echo time, distance traveled divided by time taken, but you have here twice depth of the sea, because the sound is traveling to the seabed and back. Depth of the sea divided by echo time. When you substitute, you have here depth of the sea is given. Check that you have consistent units, and echo time is, sorry, it's 1.3. It's 1.3 seconds. So the answer is 1538.46 meter per second. Here we have two important points. First of all, your result, your answer, is it realistic? Yes, it's realistic, because you know that sound travels faster in solids and you can estimate the values. It's somehow faster in liquids than gases, so you can choose this answer. The second point is only the final answer should be rounded. Only the final answer should be rounded. Question 5. Sounds are produced by vibrating objects, for sure. Now while I am speaking, my vocal cords are vibrating, so you can hear my voice. So sounds are produced by vibrating objects. A certain object vibrates, but a person nearby cannot hear any sound. Why? Which statement could explain this? First of all, amplitude maybe is too large. Okay, so you can hear the sound, but it will be loud. So this is not the case. The sound waves are transverse. No, sound waves are longitudinal. The speed of sound waves is too high. Even the speed is too high, like the speed of sound in solids. We can hear the speed of sound. Okay, so the only reason is the frequency of vibration is too high. So B is the correct answer. Let me remind you that we have what we call it the audible hearing range. The audible range is range of frequencies between 20 Hertz and 20 kilohertz. Within this range, you can hear any sound produced between this range of frequencies. But what we have here, if you have here any value exceeding 20 kilohertz, we call this ultra sound. And if you have any value below 20 hertz, we call it infrasound. Okay, so the prefix ultra refers to frequency. So it means sound waves, their frequency exceeding 20 kilohertz. Is it clear? So the reason here the person cannot hear this sound, that the frequency of vibration is too high. Question 19, here we are comparing again frequency and amplitude. Amplitude, it's the maximum displacement from the rest position, this is called rest position, okay, to crest or trough. So we have this distance, this vertical distance from the rest position, or this distance from the rest position to the trough, this is called amplitude. So if you compare A and C, you will find that C, it has smaller amplitude than A. The question is asking you about 4 waves and which one it has largest amplitude and at the same time it has highest frequency. Frequency means number of complete vibrations, oscillations, cycles produced per second. To compare frequency, as we said earlier, if you have the wave equation, the higher frequency means shorter wavelength. So when you compare wavelength here, this is wavelength, here wavelength, here also we have here also this is wavelength, and also here we have wavelength. You have to choose shorter wavelength to be related to highest frequency. So you have to exclude B and D. You have to compare A and C to have largest amplitude and at the same time you have highest frequency. Largest amplitude, if you compare A and C, you'll find that here you have largest amplitude and shorter wavelengths at the same time. So the correct answer here is A. A is the answer. Question 20 is also very, very important. Again, guys, we are discussing ultrasound. So ultrasound, they are sound waves. They have the same properties as sound waves. They are longitudinal. Maybe their speed are approximately equal to the speed of sound in each medium and so on. The only characteristic which is special for ultrasound is higher frequency. As we said earlier, the audible hearing range, they have frequency ultrasound, they have frequency exceeding the audible hearing range. If you have the audible hearing range between 20 hertz and 20 kilohertz, so you can find any value exceeding 20 kilohertz. Here it's frequency producing ultrasound. Okay, so the correct answer here, it has higher frequency than the audible hearing range. And for sure it's longitudinal wave. It has the same properties as sound waves.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.